posted all these study materials, and here are the answers to those two multiple choice things I just gave you. Right there, it says answers. Now, it is only the ABCD answers, and he has these multiple choice things for a whole bunch of units, and he just put all the answers in one spot. So this is units 2 and 3. So you can at least see if you got the answer right or wrong. There's obviously no explanation, but that would be better than nothing. So there are the answers to those, not the problems you just did for homework. So please don't look at that and try to figure out what's going on with the homework, because different problems. Now the answers to the homework problems are here. I did post those yesterday, and it's just an old PDF of all my work that I scanned. So you can go there and check those if you want to, and they are available for you. So now, why don't we talk about whatever you have questions about, which is probably nothing at all, because this is easy stuff. We don't do hard work in here. This is like a cakewalk class. What do we have? 9. We're probably going to get a lot of the same questions. 9 is a great question. I really like 9. Third period asked for 9 as well. What else while I'm grabbing? 7. Next. Hey, just let him realize when we go over it. 7 is a problem that when you see how to do it, you're gonna be like, really, that's it? But it's asked in a unique way, which can throw you for a loop. So, what else? I want to do number 14 and 16. Those are 2 questions that I assigned for the purpose of teaching you something about the calculators. Although 14 is not really teaching you anything new, but 16 absolutely does. Anything else? Any other questions? Sure. What numbers did we have? 1 is E. 3 is A. 5 is B. 6 is A. Is where's 7? There it is. C. B. A. 7 C. 8 B is in Bravo. 9 Alpha. Do I need to go military letters? That'd be easier. What else? 13 is E. What else? 14 is E. 16 is D. 18 is D. 19 is C. 19C. Oh, wait, I'm sorry. That was 20. It was under 18. Where's 19? My bad. 19 is B. 19 is B. I'm sorry. 16 is D. And I am going to go over 16. So, all right, let's look at the ones I grabbed. And if there are others that you want after I go over these, we'll look at those as well. Can I go ahead and grab 8? I can do that. 8. All right. Whoa, cancel. Okay, so number 9. This is a good question. We just did this. I think this is the very last one we did last period. I like this question. So we have this line, x plus y equals some number k, is the tangent to the graph of x squared plus 3x plus 1. What is the value of k? Okay, so when I see, I don't know, what do you want? What do you want to do? Okay, yeah, I see tangent and some words that make me think derivative, so I'm definitely going to find the derivative. So my derivative y prime would be 2x plus 3. And then? Right, now this question is backwards. Or I shouldn't say backwards, it's just different than what we typically see. Usually when we're dealing with a tangent and they give you a function, usually they give you the point, or they give you an x coordinate, and then we use that to find the slope. This time we have to go in the opposite direction. They gave me the tangent, x plus y equals k, and if I move that x over, I can see that the slope of this tangent is -1. Right? So here we're going in the opposite direction. We have the slope, and we're going to use the slope to find the point. Usually it's the other way around. So if I want to find my point, I'm going to set my derivative, which represents your tangent slope, equal to the slope of the tangent they gave me. And when you solve that, you get x equals -2, which is b. Right? Ha! Don't circle that. That wasn't the question. But they like to do that. They like to do that. They didn't ask what is the x coordinate of the point of tangency. They said what is the value of k, which if you want to think in other terms, it's the y-intercept of the tangent. Right? So now that I have the x coordinate for my point of tangency, what else could I do? I can plug that into the original function to find my y value. So -2 squared is 4. 3 times -2 is -6 plus 1. And we get a y coordinate of -1. So my point of tangency is -2, -1. And we already have the tangent slope. So once I get those two pieces of information, I have my point, I have my slope. I can take those and put them in point slope form. Y minus a -1 equals -1 times, oh, what am I doing? What am I doing? Holy cow. That was completely wasted time. I just kicked into autopilot. I was like, point slope, let's write the equation. I didn't need that, did I? Although I guess since I'm here, I could use it. Yeah. Since I'm already here, I could solve for this negative. That'll be -x minus 2 minus 1 is -3. And now I can see that k would be -3. But I did do that the long way. I did do that long way just because I kicked into autopilot. Once we knew x and y, I could have just plugged in -2 and -1 here and got -3. So, whoops.
So when it says, because you have the tangent slope is -1,
Mm-hmm.
so it's like the y derivative is saying at an x value, the slope is -1. That's why you have to pull -1.
Okay, say that again.
Okay, so you got from the x plus y equals k.
Yeah.
You got the tangent slope is -1.
Right.
And then your y derivative equals 2x plus 3
Mm-hmm.
-1 is saying that at an x coordinate, we're trying to find the slope of the coordinate.
Right.
Okay.
Yes, you said all that correctly. Good on 9? Okay. Number 8. 8's a quick one. Just be careful. By the way, this could have been a calculator question. On the calculator portion of the test, there are 2 types of questions. I mean, there's a lot of types, but as far as calculator usage, the questions are questions where the calculator is absolutely needed. Like you will not be able to get the answer without a calculator. There are other questions on the calculator part where the calculator won't help you even if you want it to. So it's like 2 ends of the spectrum. Either the calculator is no help whatsoever or the calculator is absolutely necessary. They won't ask you questions where you could answer it by hand, but the calculator will help you, if that makes sense. Anyway, I'm just rambling here. They gave me a function f. They want you to find which of these is equal to f prime of 2. So if f of x is h of x squared minus 3, f prime of x is a chain rule. It'd be h prime, leave x squared minus 3 alone, times the inside derivative. And then we're plugging in 2. F prime of 2 would be h prime of 2 squared minus 3 is 1. 2 times 2 is 4. So that's 4 h prime of 1. Okay? Moving on. Moving on. Number 7. We're going backwards. I like 7. It's a little bit unique. So we have the line tangent to a function at the point 1, 7. So this is the point of tangency. That's the point of tangency. So that is the point that the curve and the tangent have in common. But then they tell you that the tangent line, actually they say the line tangent, but whatever, the tangent also goes through the point -2, -2. And they want you to find f prime of 1, which is the slope of the tangent, right? typically, if you want f prime of 1, we find f prime of x, but they didn't give you the information for that. So that's how this question is a little bit different. That may have thrown you for a loop, because if you were locking into finding an equation for the derivative, it's impossible. We can't do it. But I do know that the tangent passes through the points 1, 7 and negative 2, 2. So if I want the slope of the tangent and I have 2 points it goes through, I can just use algebra 1. F prime of 1 would equal negative 2 minus 7 over negative 2 minus 1. Negative 9 over negative 3, which is the same thing as 27 over 9, which is the same thing as 6 minus 3, which is 3. Are we good? Bad? Probably shouldn't do stuff like that. Did that scare you? Oh gosh, I just want to move the 3 closer. There he is. All right. Good on 7? Moving on. 14. You will absolutely need a calculator. You're not getting this without a calculator, even if you try. And you will need a graphing calculator. I don't think you could somehow. Yeah, I don't think you're going to be able to use a scientific calculator either. So the one thing that I don't like about this question, not that I don't like it, but you're not ready for it, is I have very briefly told you what a critical number is, but we have not talked about it in detail. So if something like this shows up on the test, I will not use the word critical numbers. I won't use that phrase. But we have answered this question before, and it was worded not with the phrase critical numbers, but it would be how many horizontal tangents. So how many horizontal tangents does the function have on this interval? That's what a critical number is. A critical number is places where the derivative equals 0, and we've done that. So if I want horizontal tangents, I need f prime to equal 0. So we need f prime of x. This is a calculator question, and your calculator does have a built-in derivative finder. So you could use that. That's the advantage a CAST calculator gives you that a non-CAST does not. However, you won't have any problems. Like, you're not going to be asked questions where you need to use that derivative command. Now, derivative at a point will be used, but the general derivative is not a command that you need to know how to use. It would help you on this one, but that is not a prohibitively difficult derivative. So I think for the sake of practice, we should do this derivative by hand, then go to our calculator. This is a product rule. So that'll be derivative of the first times the second plus. By the way, we're about to use calculator, so if you don't have one and you want to go grab one, drop your ID in the slot, please. So I should not stop in the middle of a step. Okay, so I did derivative of the first times the second. Now the first times the derivative of the second, which will be negative sine. I'm just going to change this plus sign to a minus. Negative sine of x squared times the 2x. So we have to chain rule cosine of x squared to get the derivative of the second piece. Good. Now we need to find out when this guy is equal to 0. Here's where you have to have a calculator. These are trig functions, so you would definitely want to avoid the solve command. The solve command will do something really weird and scary. I'm going to graph that equation, and then I'm going to count. And notice it doesn't say what are the critical numbers. It doesn't want you to actually solve the equation. You just need to know how many solutions exist. You could. The problem with that is there's one spot, I think, maybe not. Yeah. Sometimes your graph, like if the derivative is equal to 0, yes, if you have a max or a min, that would be a 0, but sometimes you have an inflection point like this, where the slope is temporarily 0, and if you're looking for maxes and mins, you won't catch that one. Yeah, I would use the derivative to do this. It's just safer. All right, so let's go to the calculator, and I'm going to teach you maybe 2 things. I'm probably definitely. Is that an oxymoron or contradictory? I don't know. Okay, so I've got stuff in here. If you have anything in the calculator that you need to get rid of, if something is in there previously and you want to clear it out, if you hit doc, and this is assuming you're in the scratch pad, which is where I always am. I'm never in new documents. You go doc, and down at the bottom, you'll see option B is clear scratch pad. I just hit doc and then the letter B on the keyboard. That wipes everything out. Just make sure that before you do that, you are completely through with everything that's on the screen, and you will never need to see it again, because you will not ever see it again if you clear scratch pad. So I go to my graph screen. I'm going to solve this graphically, and I'm going to enter this big long equation, 2x cosine x squared, 2x trig cosine x squared, close parentheses, and move on to the sign. So negative x squared sine of x squared times a 2x. And I think I punched all that in correctly. 2x cosine x squared minus x squared sine x squared 2x. Looks good to me. But, and I can go a lot faster than you because the keyboard makes things a little bit easier for me, a keyboard and a mouse. But when I hit enter, I see nothing. When I hit enter, I see nothing, even though it looks like I punched everything in correctly. And this is where, like, knowing how to use your calculator is one thing. You also need to learn how your calculator thinks and how your calculator reads your inputs, because sometimes you can run into errors like this. So let's go back up here and look at my entry. And Riley, I think you were trying to correct my mistake, but I ignored you because I was trying to make a point. But what is my mistake? Yeah, if you look at where it says x cosine x, on paper, that's how we as humans write it, and we as humans can read it and understand what it says. A calculator does not have that type of thought process. A calculator sees a string of letters and assumes that string is one command. So right now the calculator is very confused because it doesn't understand what the command xcos means. And that's why it didn't graph anything. So all we have to do to fix that is we have to put something in here to separate the x from the cosine. And I like to use a multiplication dot. Now, you'll notice without the dot, my cosine was in italics. That means it doesn't understand what it is. But when I put the dot, the cosine swapped to not italics. What is the word for not italics? Is there a word for that? We need to come up with a word for that. Yeah, normal. Can't use x. Now you're gonna think perpendicular. Anyway, so that's one thing you can look for. If you notice that your letter, the command you're using is still in italics, that means there's an error in the input. Now if I hit enter, now we see our graph, and we're supposed to count. And remember, we're not finding the solutions, we're counting the solutions. And there are an infinite number of solutions. But back to the question, we're only interested in the solutions from -2 to 2. This is another reason I prefer the solve command, because if you're, no, I'm sorry, well, I prefer solving graphically, because if you're using the solve command, it's a little bit trickier to limit the solve command to a specific window. It can be done, and it's really not that difficult, but I just don't like doing it. I don't trust the solve command. So I'm going to go back to my graph screen, and this is from -10 to 10. That's way too much. I'm going to adjust my window by going menu, window zoom, window settings, and I'm going to say, just show me what's happening from -2 to 2. If you only show me -2 to 2, now I can look at that. And remember, we're not finding the solutions. We're only counting how many exist. We're only counting the number of solutions, not finding the actual solutions. And how many do you see? I see 5. I see 5. Are we good? 1, 2, 3, 4, 5. That would be places where, yes, because those are places where the derivative is equal to 0, right? And that means the slope is 0. And also, if you go back to the derivative sketching stuff we did, any place you had a 0 slope, which was a max or min, that's where we put our derivative graphs on the x-axis. So the maxes and mins. Okay, yeah, this is what Ashford was asking a minute ago. It would work on this particular problem, but the danger in that is sometimes graphs will like have a minimum, and then they'll have like a 0 slope like this, but then continue going back up. And those inflection points where the derivative is equal to 0 may not be as easy to see if that's your thought process. So I really want you to train yourself to think horizontal tangents, critical numbers, find the derivative and set equal to 0, because you're not going to miss them that way. Good, bad, ugly? Number next. And 16 is another one where I want to teach you something new about the calculators. And for the sake of time, I think I'm going to go through this one a little bit, not give you the time to answer and guess and whatever. Let's see. So we want the equation of a line tangent. And when I think equation of a line tangent, I want point and slope. But, it happened again. Usually you're given the point, and we use the point to find the slope, but they didn't do that this time. They left the point unknown, but they did say the point where the derivative is equal to 1. And so what we know is that the slope is equal to 1. All right, so this is backwards, kind of like the problem we did a minute ago. We have the slope. We're going to use the slope to find the point. And so if I know the slope is 1, that means my derivative, which is 4x cubed plus 4x, that needs to equal 1. And we're going to solve this equation. That'll give me the x. And then I can use the x to find the y. All right? So this one is going to be, sometimes when I solve equations like this, I will definitely do graphically. I am going to graph again. This time I'm going to move that 1 over, 4x cubed plus 4x, and I'll subtract the 1. And I'll just graph the one thing and find the x-intercept. Okay. Now, you could graph 4x cubed plus 4x and then graph 1 and find their intersection. That's fine also. So I'm going to go back to my calculator. I am through with this problem, so I'm going to do that trick I showed you earlier. Doc B clears everything out, and I need to graph 4x cubed plus 4x. Oh, that's not a cube. 4x cubed plus 4x minus 1. Yeah. Minus 1. And I'm graphing that. And I want to find the x-intercept, and there's only 1, thankfully. So I'm going to go menu, analyze, intersection. Nope, 0. And we talked about how to solve equations the other day, so I'm hoping that you can do this. I know you're not as good at it as I am, because I've been doing this for a little bit longer than you've been alive. I think. Yeah, I definitely started doing this in high school. Haven't been teaching it for longer than you've been alive. Almost. Maybe. Riley, you'd be the youngest one here. How old are you? Yeah. Yay, I've been teaching here longer than you've been alive. Anyway. That point? Okay, so you go menu, analyze, and this time I want the 0 of the graph. I want to know where the graph hits the x-axis. And when you do that, it gives you this dotted line. You go one side of where the 0 is, click, move to the other side, click, and that'll give you that point. Now, if you're only looking at 3 decimal places, if you only see 0.237, you need to go into your settings, menu, settings, and change display digits to float 6. For this particular problem, it's not an issue, but there will be problems in the future where if you don't have float 6, you're not going to see enough digits to get full credit. So I'll go float 6. Now, here is what I wanted to teach you. I have solved the equation, and I do know that x is equal to 0.237. However, I need to use that point. I need to use that x-coordinate to get the y-coordinate. And to get the y-coordinate, I'm going to have to find y of, or actually f of 0.237. And for this particular problem, you would be okay using the value 0.237 into f of x. You would get away with it. What is the danger, though? Do you know? 0.237. Yeah, we might not preserve third decimal place accuracy because that is a rounded answer. It's dangerous to use rounded answers in intermediate steps. So what we're going to do, I will on paper write 0.237, but in my calculator, I'm going to save that answer. I'm not going to write down a whole bunch of decimals. I'm going to store the answer for, I like to start with A. And that way, if I hit A in my calculator, I will get all the decimal places, not just the first 3. And this is reason number 17 why I like to solve graphically instead of using the solve command. storing your answers from the graph screen is a whole lot easier than storing your answers after a solve entry, after a solve command. All you do is you move your cursor over your x coordinate, which is what I want to save. I don't think I ever need to save the y's. Everything's always tied to x. And you click and move your cursor away. It should be highlighted or it'll be just a faint gray. Either way, it's going to look different than the y coordinate. Move the cursor off of it so you can see it. While it is highlighted, if you look above the var command, there are blue letters STO, that stands for store. We want to store that decimal, so I'm going to hit Control, Store, and it'll ask you what variable do you want to assign to this value. You can call it anything you want. I definitely would not use x because x is, I don't know, x is usually an unknown, right? So I usually start with a, and I'm just going to hit the letter A, hit enter. And when I do that, you'll notice the x coordinate turned to bold. That means you successfully stored it. If you forget what you stored it for, you can mouse over and it will tell you, hey, that's linked to the letter A. There's your reminder. Good, good? Now that it's stored, if I go back to my compute screen, if I hit the letter A and enter, it'll display all the digits. So now the calculator is seeing all of those decimal places when I hit A, and it preserves accuracy. And that's very important. It's not going to matter in this particular problem, but there will be problems later on this year. If you don't store your answers and you use a rounded value, it'll end up not giving you that accuracy you need to get full credit. So I'm going to punch that in. This is A, so it'll be A to the fourth plus 2 times A squared. So I simply type in exactly that, A to the fourth plus 2A squared. So not only is it more accurate, it's more efficient. It's a lot quicker to just type that in than have to enter the decimal value every time. Hit enter. We have our y coordinate of 0.115. And so now I have my point. And now we just find the equation of the tangent. Y minus 0.115 equals 1, x minus 0.237. And that will, when you solve for y, end up being D. Are we good out there? Good? Yes, ma'am.
So last night I used Desmos
Mhm.
for the website.
Mhm.
So the way I solved it, I just put the initial function as the x fourth plus 2x squared.
Okay.
And then I realized like some of them would have y intercepts that were like above it or like going through the graph.
Uh-huh.
So I excluded like A, B, and C that way.
Okay.
And then could you like put in the other lines?
So yeah, you could. It's going to be. I don't know if that's quicker or not. So were you? So you graphed on Desmos. Were you just trying to imagine where a tangent of slope 1 would be?
Yeah, I kind of like. I kind of trial and error too. I just put those in, but then I realized that you would know that too because the way the initial graph is, I think it's like on the x-axis.
That's an okay way of doing it. I don't know if it's going to be as efficient. Like this one's not as bad, especially like you could have gone brute force. By the way, eliminate A right off the bat because it doesn't even have the right slope. Once you establish that the slope needs to be 1, A is gone. And then you could graph f of x and then one at a time graph each one of the 4 and just see which one happens to give you a tangent to the original function. And that would work, which is kind of what you're doing. Yeah, and that's So that's a valid thought process. It may not work every time, but the way we solve it would be the foolproof. Doesn't matter how ugly the function is, but yeah, you could do that. Good, good. Looks like that was all of them that I screenshotted. Okay, so were there any others? We still have about 20 minutes, 15 minutes maybe. Any other? One more thing. Sorry. If this were a free response question, which it's not, it's multiple choice, so who cares what you write down? But if this were a free response question, you are allowed on your paper to write, and I would encourage you to do this. I would write let A equal 0.237. Because if you, on your paper, declare that A and 0.237 are the same, then from that point forward, you can actually use the letter A in your written work and not write down the decimal. And that's okay. As long as you make notes somehow, I like to make it a little bit more formal. I like to actually say let A equal whatever. It's okay if you want to just say, hey, arrow, this is A. That's an indication that we've stored it for A's. Any designation that the letter A represents 0.237, from that point forward, you can use the letter A in your written work. You have to write down 3 because you have to have 3 decimal place accuracy. So make sure you have that third decimal. But once you've established that third decimal place and what the value of A is, you don't have to rewrite it. You can just write the letter A in its place. Mm-hmm. Mm-hmm. Yeah. All right. So what other ones would you like to look at? 19. That was the inverse one, is B, positive, the slope of 1/4. Any others that you would like to look at? Any others? And again, the answers are up now with my work. So you have that out there. Last period told me that the AP Classroom thing was not an option, was not available. Because I did give you that optional AP Classroom assignment. And when I opened up the settings, I think I accidentally set the due date for September 1st, which it seems like it should have flagged that. You're setting the due date for a time before you actually assigned it. I'm surprised it even allowed that. But if you tried to get to the that progress check that I told you was optional and it wasn't available, it should be available now. Any other questions? None at the moment? Okay. Huh? Yeah. I want to look at Patrick Cox's things. Yep, that's exactly what I wanted to do because we have not done any of those yet. Yep. Reading my mind. You want to teach? Okay. We talked very briefly the other day about your inverse trig functions. And so I want to do a couple, like here's 2 right here. Numbers 55 and 56. This is on the Patrick Cox unit 3. And the numbering, what he did is he put 20 questions per unit. So unit 1, which I didn't give you, is numbers 1 through 20. And then unit 2 is 21 through 39. And unit 3 is 40 through 59 and whatever. So that's where the numbering is coming from. Let's look at 55 and 56. Those are inverse trig derivatives, which I told you what the formulas were, what their derivatives were, but I think this is the first time I've given you anything where you actually need to find those derivatives. So let's look at these 2. If I were to give you a pop quiz on inverse trig derivatives, how many of the 12 would you get right? 6, sorry. Okay, you need to know those. You need to know those. Okay. So this is the derivative of arctan, and you need to know that the derivative of inverse tangent, and remember arctan and inverse tangent, same thing. This one is 1 over x squared plus 1. Tangent to me is the easiest one to remember. It's the one that does not have a square root and it's addition. And fortunately, for some reason, I don't know why, but for some reason, inverse tangent shows up more frequently than the others also. So the one that I think is the easiest is also the one that you see the most. And so if that's the derivative of inverse tangent x, what would I do for the inverse tangent of 2x? It's a chain rule. They have put something inside the inverse tangent. Now that's your gum. That's the inside. We don't touch that until I have completely done the derivative of the outside arctan x, which is 1 over 1 plus my x, which is 2x squared. Good. So that takes care of the arctan part. So it's now done. But I have not done the derivative of its inside, and the derivative of 2x is 2. just match that to the one down here. A and C don't even have the 2 on top. B forgot to square 2 along with the x. And D, they multiplied out the 2x squared. Good. Bad. Moving on. What about 56? Arc sine of e to the x. Okay, let's start. What is the derivative of arc sine x? Good. 1 over root 1 minus x squared. But just like the last one, this is not just arc sine x, it's arc sine of something else. So we will leave that something else alone. And we'll do the derivative of arc sine first, which is 1 over root 1 minus inside squared, and my inside is e to the x. And then, now, we multiply by the inside. What is the derivative of e to the x? E to the x. So which of these 4 is that? C. Remember, a power to a power, you multiply. I'm kind of surprised they don't have e to the x over root 1 minus e to the x squared as an option for the people who forget what you do when you have a power to a power. Right? But Mr. Cox is a nice person. He didn't try to trip you up too much. You multiply power to a power. I want to talk about those because we, as far as inverse trig goes, all I did is I threw them up on the screen and said memorize them, and we haven't looked at them since. Questions, comments, concerns? The rule about e, the derivative of e to the x. Well, yeah, I'm going to go a little bit more detailed. The derivative of any constant to a function power is the constant to the function power. You just copy it as is times the derivative of the exponent. Right? And that's true for e to the x also. Right? By the way, I'm going to have to add something else to that. The derivative to e to an exponent is e to the exponent times the derivative of that exponent. And for e, we stop there. That's your chain rule for e to the x. If it's not base e, if it's 2 or 3 or 7 or 10, anything else, you also need to put the natural log of the base on the end. Now that's rare. We don't see those very often. And because we don't see them very often, we tend to forget that. But that's there. And it is technically there for e to the f of x as well. But what is the natural log of e? It's 1. So if you want to just do it every single time, that's fine. But you need to know that natural log of e is 1, so they will not write that on e derivatives. Is that the question you were asked? Is that what you wanted, Connor? Okay. Are we good? What else? We have about 7 or 8 minutes. Yeah, let's see if we're a log 1. Do y'all see a log 1 anywhere? That may be unit. Yeah, 48's one. There's one. Okay. 48's going to be a quick one. We'll see if we can find a more complicated one. Because 48 is going to be basically what Connor just asked, except for natural log. The answer to 48 is just your memorized rule for the derivative of a natural log. And the rule for a natural log is? The derivative of the natural log of anything is, what did you say, 1 over x? Yeah, if it's natural log x, it is 1 over x. But if the inside is uglier, that invokes the chain rule. So instead of 1 over x, it'll be 1 over g of x. But you would multiply by the derivative of the inside, and instead of putting it off to the side over here, I just stick it in the numerator. So the derivative of natural log of g is g prime over g, and that is the chain rule. Just remember that includes the chain rule. We tend to just memorize that derivative and sometimes forget that we are doing the chain rule, and then we accidentally double dip into the chain rule. We multiply by too many g primes. All right. Now, technically, and I'll extend this to logs that are not base e, if it's another base, we do the same thing for a natural log. We put the argument, we put the interior on the bottom, and we put its derivative on the top, but then you multiply the denominator by the natural log of whatever the base log base is, which again is part of the e, the natural log base e, but when I do that in here, the natural log of e is 1, and so we don't write it. And fortunately, we don't see too many logs that are not base e. Almost every one of them will be natural logs. Are we good? Is there another log on this sheet? That one was like really straightforward. Oh, on the other, okay, so it's in unit 2 then, okay. Or his unit 2. 23. Okay, 23 is a good one. There was one like this in the homework as well. It's presented as a limit, but you're not expected to actually solve this as a limit. You're expected to look at that and identify the hidden question, because this limit is in the format of the limit as x approaches a, f of x minus f of a over x minus a. It's one of the two limit derivatives, which gives you the slope of the tangent at a. So I'm not going to answer this as a limit. I'm going to find the hidden question. This is asking you to find f prime of, they're plugging in 3, x approaches 3, if f of x is equal to, and the f of x is natural log of x. So if you can find that hidden question inside the limit, we can ignore the limit. If f is natural log x, f prime is 1 over x, and f prime of 3 is 1 over 3. By the way, we will learn L'Hopital's rule at some point, which will give you another option for solving these limits. But it's no quicker than this. This is just the quickest way. 38. Hey, that's a number before 39, isn't it? I was right. This is a fun one. I wonder if these are calculator or non-calculator questions. I wonder if he designates any problems as calculator active. So we have f is a differentiable function, and it is the natural log of x over h of x. And they ask for the value of f prime of 1. Whoops. What would f prime of 1 end up being? Well, we have to find f prime of x, which would be, good, a quotient. We have like 3 minutes, so I'm going to go a little bit faster. Low d high 1 over x minus high d low, which would be h prime of x all over low h squared of x. And here is where we use these values. They tell you what h of 1 and h prime of 1 are, and they both equal negative 2. So f prime of 1 is going to be h of 1, negative 2, times 1 over 1, minus natural log of 1. Ooh, we have to remember that. Times h prime of 1, which is negative 2, all over h of 1, which is negative 2, all squared. And what is the natural log of 1? It is, okay, beauty of multiple choice. Which one would it have to be? Would it be 0 or would it be e? Okay, obviously it's not e because e is not in any of the answer choices, right? But you need to know that natural log of 1 is indeed equal to 0, which just wipes out that second term. And so we're left with negative 2 times 1 over negative 2 squared, which is negative 1/2. Good. And then again, if you forget stuff like that, if you can train yourself to think graphically, you should know that the graph of natural log x looks like that and crosses the x-axis at 1. And so if you want to think graphically, at x equals 1, my natural log value is 0. We are on the x-axis. If that helps you process and rather than take the guesswork out of stuff. We good? Okay, no assigned homework tonight. I just want you to study. You have 3 things of multiple choice questions in front of you, plus the progress check that should be available in AP Classroom. That one is optional. And I will see y'all tomorrow.